Okay, let's give you guys some more practice. So here, given that y equals 2x to the power 3, find dy by dx. So start out by sketching this graph. So it will look something like this. Normally your y equals x to the power 3 would look like this. And then 2x to the power 3 will be a lot steeper. Okay, so it will look something like this, and then set up your A, set up your B, and then get B to move towards A. Okay, so well, press pause and have a go. Okay, so to well, start out by sketching your graph. It will look something like this. It will look something like this, and then set up your A, set up your B, and then inside your mind, try well inside your mind, think that, well, currently the gradient that exists between A and B is given by f of x plus h, take away f of x, and then divided by h being this length here. Okay, and then the next, so start by sketching the graph, and then set up this system here, and then inside your mind think, currently the gradient that exists between A and B is given by this. And then now the true gradient, which is dy by dx, the true gradient is when you start to take the limit as B moves towards A. So take the limit, and the way you get B to move towards A is to decrease h each time. So take the limit as h tends to 0 of f of x plus h, take away f of x divided by h. Okay, so now this here is your true gradient. It's when you start to take the limit, or as h tends to 0. So that would take you to here. Okay, so now yeah, so remember, originally our equation was 2x to the power 3 here, and we wanted to know x plus h, take away this here, and then take the limit of this here as h tends to 0 here. You see, when you start to put this into here, x plus h here, you're going to have this 2, which is here, and then this thing here is your x plus h here, and then you've got to cube it. Okay, and then take away the original f of x. The original f of x was this here. So well, that would take you to this stage here. Okay, and then from here, it's just a matter of using algebra now. You've got to do this first, to the cube x plus h. So when you cube it, think of it as this thing times by itself 3 times. So now merge these two together. So that, well, that will be yeah. So when you are here, merge these two together. Try to multiply these two out. So that will be x times x, that will give you x squared. X times h, that will, and then later on you're going to get h and x here, that will give you 2xh, and then h times by h, that will give you h squared. So my point is that merge these two together, that will give you this thing here. Okay, and then now hang on, and then now you've got to do this times this, that will give you this, and then this times this, that will give you 2x squared h, and then this times this here, that will give you this thing here, and then now this times this, that will give you this, this times this, that will give you this times this, that will give you this here, and this stays the same. Okay, and then oh, it's gone off screen again. Wait there. Let me move it across. Wait there. Something like this. Hang on. So don't forget, this is 2x to the power 3. This is 2x. This is a 3 to the power of 3. Okay. Well, from here, then get this times this. That will give you this. This times this. That will give you this. This time, well, it's just basic algebra really. This times this, blah blah blah, this times this, that will give you this. This times this, that will give you this here. This remains the same, okay? And then hang on, and then that will take you to here. So so what next? Let me think. Sorry. What next? Okay. So this here you've got minus 2x to the power of 3. Let me move this across here so you can see. Okay. Hang on. Oops. Bear with me. Hang on, bear with me. So here you've got 2x to the power of 3. Here you've got minus 2x to the power of 3. These two will cancel out. Okay, and then there was something else. Let me think. I think. Let me think. Oh yeah, this thing here. You've got two of this thing, and the exact 4 of this thing here. So these two can merge together, giving you 6xh squared. Okay, it's like you having 2 Ligers here plus 4 Ligers here. That will give you 6 Ligers. Okay, well, I hope you know what I mean. So this whole thing here simplifies to this. Okay, and then now, so now look at this. H is in common here. H is in common here. Let me start again. H is in common here. 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 Factor out the H, so that will give you this. So factor out the H here, and these two will cancel each other out, giving you this. Hang on. So hang on. Let me move it across now. Okay. So we are currently here. Now, are we? Yeah. So these two will cancel out, giving you this here. And now take the limits as h tends to 0. You see, as h tends to 0, you've got 6x times. Well, as h tends to 0.0000. Well, consider this whole term here to disappear, and then this term here will also disappear, leaving you 4x squared plus this thing here. Okay, now these two will simplify, giving you 6x, giving you 6x squared. So dy by dx is 6x squared. Okay, so let's go back to the hang on. Let's go back to the start here. So originally it was, hang on, bear with me. Originally it was y equals 2x to the power of 3. Dy by dx is actually 6x squared. We just worked it out from earlier. So when you look at the graph here, hang on. So when you look at the original y equals 2x to the power of 3, our graph will look like this. Okay, this is a graph of y equals 2x to the power of 3. Now let's look at this point here. You see the gradient here is positive. Let's say it's here. The gradient here is still positive. The gradient here is 0. Okay, but the point is that when you're here, the gradient's positive. When you're here, the gradient's positive. When you're here, the gradient's slightly positive. When you're here, the gradient's positive. So the gradient's always positive. Whoops. The gradient is always positive. When you're looking at a graph of y to the power of x to the power of 3, the gradient is always positive. Well, this here, the gradient here is 0 here. But apart from that, the gradient is always positive. If you look at y equals x squared, it will look like this. You see the gradient here is negative. The gradient here is negative. The gradient here is negative. And then when you start to cross over to the positive side, the gradient here is positive. Gradient here is positive. But when you look at x to the power of 3, the gradient is always positive. Even though you're on the negative, even though you're on the left-hand side, the gradient is still positive. So when you look at so we starting out as y equals this. When you find the derivative, which is dy by dx is 6x squared. And when you look at 6x squared, you can see that the gradient is always positive. Look, looking at y equals 2x to the power of 3. Let's look at this. Suppose you want to know the gradient right at here. Okay, the gradient here will be you looking at, so now this is our dy by dx, this is our gradient graph. Okay, our gradient graph. The gradient, hang on, let me start again. The gradient at this point here, let's say at this point here, well, let's move this down here, so that will be at this point here. You see the gradient at this point here is actually 10 over 10, is probably about, it's 13. You see, my point is that when you're, if you want to find out the gradient here is positive, and it's actually, well, to find out the gradient at this point here, look at your gradient graph. You see, this is your gradient graph, and the gradient graph is a straight reading. It's at 13. So the gradient at this point here is 13. Now, if you want to find out the gradient here, well, at x equals 0 here, if you want to find out the gradient at x equals 0, you look at your gradient graph. This is our gradient graph, and at x equals 0, the straight reading is 0. So suppose you want to find out the gradient at this point here. Okay, at, let's say, 1 here. This x, well, 0's here, 2's here, so this must be 1. Let's say you want to find out the gradient at x equals 1. So you've got to look at your gradient graph, and when you look at your gradient graph, it's a straight reading. It's a straight reading. So when x equals 1, which is right here, it's a straight reading. It is 6, positive 6. So this gradient here is positive 6. My point is that your original graph, y equals 2x to the power 3, looks like this. But then the gradient graph will look like this. And if you want to know the gradient, it is a straight reading. So yeah, so your gradient graph will look like this. Okay?